Good morning. I am Dr. Sushmitha, Assistant Professor of Civil Engineering Department, G. Pillaredi Engineering College, Kurnool. So today I am going to discuss Module 3 of Multimodal Transportation Engineering. So the presentation consists of sleepers, functions and requirements of sleepers, types of sleepers and sleeper density. Okay, so sleepers are the main component parts of typical cross section of permanent way. So sleepers are the horizontal members which are generally laid transverse to the rails on which the rails are supported and fixed in order to transmit the loads from rails to ballast and subgrade below. So you can observe the sleepers, how they are placed horizontally in the railway track. So next is functions of sleepers. So the main function of the sleeper is to hold both the rails together in the position in order to maintain the correct gauge throughout the track. To act as an elastic medium in between ballast and rails to absorb the blows and vibrations of the fast moving loads. To distribute the load from rails to the index area of the ballast underlying it or to the grinders in case of the bridges. To support the rails at a proper level in straight track and at proper super elevation on the curves. So firm and even support to the rails is provided by the sleepers, providing longitudinal and lateral stability of the permanent track. Next, to rectify the track geometry during its service life. So these are some of the functions of the track. So what are the requirements of the sleepers? The initial and maintenance cost of the sleepers must be low. Fittings of the sleepers should be such that they can be easily adjusted during maintenance operations. Okay, so easy lifting, packing, removal and replacement must be done. Sleepers have moderate weight for ease of handling. The design of sleepers should be such that gauge, alignment of the track and levels of the rails can easily be handled, adjusted and maintained. Sleeper design and spacing should be so as to facilitate easy removal and replacement of the ballast material. So crushing strength must be more for sleepers. Sleepers should be capable of resisting shocks and vibrations due to passage of heavy loads of the high-speed trains. The design of the sleeper should be such that they are not damaged during packing process. The design of the sleeper should be such that they are not pushed out easily due to moving train. So what are different types of sleepers and what are their advantages and disadvantages? So in general, we have mainly three types of sleepers: wooden sleepers, metal sleepers and concrete sleepers. So first let us see what is wooden sleeper or timber sleeper. So wooden sleepers are the best sleepers. They will fulfill almost all the requirements of the ideal sleeper. Life of the timber sleepers depends on their ability to resist wear, decay, attack by vermin and quality of the timber which is used. So the main advantage with these timber sleepers is timbers can be easily available in all parts of the India. Fittings for wooden sleepers are few and simple in design. These sleepers are able to resist the shocks and vibrations due to heavy moving loads and also given less noisy track. They are easy to lay, relay, pack, lift and maintain. They are suitable for all types of ballast. They are best for track circuited operations. These are overall economical. So the disadvantages with these wooden sleepers is that these sleepers may be subjected to wear, decay, attack by white ants, cracking, end splitting, etc. So it is difficult to maintain the gauge in case of the wooden sleepers due to the formation of the cracks due to heavy moving loads. So due to this disturbance in the gauge, the track will get easily disturbed It has minimum service period of 12 to 15 years as compared to other types of the sleepers. Maintenance cost of the sleepers is high. So next type of sleepers are metal sleepers. So the requirements of these sleepers are same as that of the general requirements of the sleepers, that is they should bear tensile and compressive stresses which are coming onto them, and they should provide sufficient area for rails. Tamping and packing of ballast should not disturb the sleepers. For track circuiting, insulation should be possible. It should be overall economical when compared to wooden sleepers. It should provide sufficient grip on the rail and ballast to prevent dislocation of the track due to shocks and vibrations. So advantages of these metal sleepers are uniform in strength and durability. The performance of fittings is better and hence lesser creep occurs. These are economical as life is longer and maintenance is easier. Gauge can be easily adjusted and maintained in case of metal sleepers. For metal sleepers, frequent renewal is not required, easy in manufacturing, and they are fire resistant. Okay, so disadvantage of these metal sleepers is more ballast material is required when compared to other type of the sleepers. Fittings required are greater in number and difficult to maintain and inspection. Metals, cast iron or steel, are liable to rusting or corrosion. Metals being good conductor of electricity, they interferes with track circuiting. Metal sleepers are unsuitable for bridges, level crossings, and in case of points and crossings. These sleepers are only suitable for stone ballast and for rails for which they are manufactured. Next is steel sleepers. So it should the following requirements it should fulfill. It should maintain perfect gauge. Rail should have sufficient bearing area on the sleepers. Rails should not be liable of being pushed easily out of its position. It should be possible to fix the rails easily in sleepers and without moving the sleeper longitudinally. The metal sleeper should be strong enough as beams. They should be sufficiently heavy for stability. Where track circuiting exists, it should be possible to insulate them from the rails. In India, except the last case, it fulfills all the requirements. So advantages with these steel sleepers are they are casted in one piece, single piece. So joints, you can avoid maximum number of the joints. The fastening to the sleepers are less in number and simple in nature. These have inverted channel section, so they are light in weight and can easily be handled. The gauge by use of these steel sleepers can easily adjusted and maintained. Manufacturing of these sleepers can be done by simple process. The life of sleepers is much more than that of wooden sleepers. So next, disadvantages of steel sleepers. So generally if you use steel sleepers, crack develop at rail seat which need the use of saddle plate. The sleepers being metal, they are liable to corrosion. The rounded ends of the sleepers do not prevent lateral shift. These are not suitable for electrified tracks. The cost of steel sleepers is relatively more when compared to the wooden sleepers. Next, concrete sleepers. So concrete sleepers have been proved that these sleepers are ideal material for sleepers for due to the following reasons. They are made of strong homogeneous material, impervious to effect of moisture, and is unaffected by the chemical attack by atmospheric gases or subsoil salts. So it is in general molded easily to size and shape which is required by scientific investigation to withstand the stresses produced by fast and heavy traffic. So these sleepers are generally reinforced concrete sleepers and pre-stressed concrete sleepers. So So advantages with these reinforced concrete sleepers are they are free from natural decay and attacked by vermin, insects, etc. They have maximum service life of 40 to 60 years. This is not affected by any moisture, chemical action of ballast, cinders and subsoil salt. There is no difficulty in track circuiting required for electrifying the track. The sleepers have higher elastic modulus and hence they can withstand the stresses induced by fast and heavy moving trains. Better resistance against temperature variation. The high weight of the sleepers helps in minimizing the joint maintenance by providing longer welded lengths. Okay, so disadvantage with these concrete sleepers is the weight of the concrete sleeper is as high as 2.5 to 3 times the wooden sleeper, so which requires mechanical appliances for handling. They damage the bottom edge during unpacking. The scrap value is almost nil. The damage of the concrete sleepers is very heavy in case of the derailment. So when you use pre-stressed concrete sleepers, all the disadvantages of reinforced concrete sleepers have been eliminated by using pre-stressing technique for sleepers. The concrete is put under heavy high initial compression. The design is based on maximum permissible compressive strength of the pre-stressed concrete sleepers is 211 kg per centimeter square. Minimum crushing strength must be 422 kg per centimeter square when you cured it at 28 days strength. The pre-stressed wires are stressed to an initial stress of 8.82 kg per centimeters square. So disadvantages of pre-stressed concrete sleepers are they are uneconomical, they are more rigid in nature in general, the bed of the ballast is specially prepared, these are heavily damaged in case of derailments, the design and construction is complicated, the standard of maintenance for track is to be kept very high. Okay, so these are different types of sleepers with advantages and disadvantages. So next, spacing of sleepers. So a small topic, that is sleeper density. The space between any two adjacent sleepers determines the effective span of the rail over the sleepers. So this spacing depends on axial load which the track is expected. So the number of sleepers in the track is indicated by number per rail length. So minimum spacing required for sleepers for packing of the ballast is specified. In India, for manual packing it is 30.5 to 35.5 centimeters except in the case of joints, and for tampering it is 25 centimeters. Number of sleepers for rail varies in India from M+4 to M+7 for main tracks, where M is the length of the rail in meters, N in place of M is used, then N is the length of the rail in yards. So what is meant by sleeper density? Sleeper density is nothing but number of sleepers per rail length is called sleeper density. So sleeper density is specified as M+X or N+X. M is length of the rail in meters, N is the length of the rail in yards, X is the factor which depends on several other factors. So it is a number which depends on several factors. If M is the, for example, if M is the length of the rail in meters, sleeper density is expressed as M, M+1, M+2 and so on. So for instance, if the length of the rail is 13 meters, that is M is 13 meters. So number of sleepers required as M+4, that is 17. 17 sleepers are required. Thank you.